Good afternoon. We are going to see the next experiments in the dynamics mechanical measurement lab. That is what study of slip gauges. Slip gauges are usually accepted standard in length in industry. They are working standards of linear dimension. So it's a model slip gauge I am showing here. So it is a accepted standards of length. Using this, what we can do, we can calibrate any length. Like if I want to check a micrometer, I can use this. I want to check a vernier caliper, I can use this. I want to check some other length. So it is working like a gauge blocks. This is called as gauge blocks. So each and every slip gauge is having some dimension. So it have 1.005 mm, 1.001 mm, 1.002 mm, 1.003 mm. Like that, it will be varies from 1.005 to 100 mm. So up to 100 mm, the various types of slip gauges are available. So the slip gauges also having different grades. So grade, the name of the grade is grade 2. That is a workshop grade. It is a workshop grade. It includes setting up of machine tool, positioning of milling cutters and checking mechanical bits like that. We can use this grade 2 slip gauges. And then grade 1 is used for precise work such as classroom tool. Typical includes setting up sine bars, sine tables, everything. And grade 0 is an inspection grade that is used for tool room or machine shop inspection. And grade 0 is a standard room. It should be kept in a standard room, and it have a very high precision value. And using that, we can measure any machine tool to precise. Calibration grade. Calibration grade slip gauges are used for calibrating that I already told. I want to check a vernier caliper. It is having 1 mm. It is showing 1 mm or not. Using 1 mm slip gauge, where is 1 mm here? In 1 mm slip gauge, I can take 1 mm slip gauge. I can measure this one, and I can check the vernier caliper is showing 1 mm. Like that, if I want to check a micrometer or screw gauge, I can take any one of these and I can check. Using this, we are going to do one experiment that is called calibration of sine bar. So that sine bar, what is sine bar? We should know. A sine bar is an arrangement for finding angular dimensions. So here, this is your sine bar, and a workpiece having some slope. To find the slope, we are going to keep the sine bar. We are going to keep the workpiece on the sine bar, and then we are going to lift it by using these slip gauges. By using the slip gauges, we are going to lift it, and we are going to make the taper parallel to the surface by using some dial gauge. That also I am going to show you. So using the dial gauge, we are going to make the tapered surface as a parallel surface. After that, using a triangular calculation, we are going to find the angle of the particular taper or workpiece. That is we are going to see. So here, this is your slip gauges I am showing, and this is what your sine bar. The sine bar, the general arrangement of sine bar, so is like this. So generally the sine bar, what is the specification of the sine bar? That one we are going to see. A sine bar just a minute. The distance of the sine bar is nothing but from this, there are having two rollers here. The distance between the two rollers will define the sine bar's length. Okay, so 150 mm length, 200 mm length, 250 mm length, like that. The various types of sine bars are available. According to the distance between the roller, only the sine bar length is specified. On that, we are going to keep a specimen taperly like that. So it is a drilled dead center. Let dead center of your death and the spindle. So here it is having some taper. That taper we are going to measure by attaching it in a sine bar. After attaching it in a sine bar, we are going to fix a dial gauge. So this is our dial gauge. So using this dial gauge, we are going to touch both the edges. From here we are going to touch the whatever dimension here showing, the same dimension here it has to show. So up to that, we are going to add slip gauges at the bottom of the sine bar. So here we are going to lift at one side. At the lifting area, we are going to attach the slip gauges. So the slip gauges will be attached at the bottom and it will be lifted like this, and the dial gauge will be monitored for making sure that whatever here I am measuring 1 mm means the same measuring 1 mm should be measured here. Like that we have to touch both the end. When you move, the dimension should not change in the dial gauge. Like that we are going to check. After that we are going to find the values.